Hello everyone and welcome back to Up 360 Circuits, your go-to channel for electronics tutorials, embedded systems and practical IoT projects. In today's project, we will be comparing two popular object detection sensors used in electronic and automation systems, the E18 Infrared Proximity Sensor and the Infrared Obstacle Avoidance Sensor, commonly known as the IR sensor. We would also be using the Arduino and some jumper wires. Both sensors are designed to detect the presence of nearby objects without physical contact. These sensors are commonly used in robotics, industrial automation, object counting systems, obstacle detection applications, and smart embedded projects. Although both sensors operate using infrared technology, they differ in terms of detection range, reliability, adjustability, and practical applications. In this video, we would examine their connections, test their performance, compare their features, and discuss the advantages and limitations. Let's begin with the E18 proximity sensor. This sensor detects objects by transmitting infrared light and receiving the reflected signal. It combines an infrared transmitter and receiver inside a single enclosed housing. Some of its key features include adjustable detection distance, digital output signal, long-range object detection, and improved resistance to ambient light interference. The detection range can typically be adjusted from approximately 3 centimeters up to 80 centimeters depending on the object being detected. Next, we move on to the IR sensor. The sensor also uses infrared transmission and reflection to detect nearby objects. Unlike the E18, it is designed primarily for short range detection and educational electronics projects. Some of its key features include compact design, low cost, easy integration with Arduino systems, and adjustable sensitivity. This sensor is commonly used in obstacle avoidance robots and beginner electronic projects. Now, to compare both sensors, the E18 can be used approximately from 3 centimeter to 80 centimeter, while the IR sensor can be used for 2 centimeter to 30 centimeter. This makes the E18 more suitable for applications requiring longer detection distances. In terms of reliability, the E18 offers an enclosed optical design which helps reduce interference from surrounding light sources, while the IR sensor can be more sensitive to environmental lighting conditions, especially when exposed to bright sunlight. As a result, the E18 provides more stable performance. In terms of size, the IR sensor is smaller and more compact, while the E18 is a little bit larger and requires more installation space. Therefore, this makes the IR sensor suitable for compact robotic systems. In terms of cost, the IR sensor is generally less expensive and more commonly used in beginner electronics kits, while the E18 is more expensive but offers improved performances. So, in short, if your project requires long detection ranges, adjustable sensitivity, and stable operation, the E18 could be a better sensor. And if you need something low cost, compact, and easy to use, and also suitable for beginners, the IR sensor can be your go-to. Now we move on to how these sensors can be connected. Connection wise, the sensors are quite similar. Both have 3 connection pins. Let's start with the E18 sensor. It has 3 pins, just like I said, 3 wires rather. the brown wire for VCC, the black for out, and the blue for ground. So to connect it, just attach a wire, just like I've done, a jumper wire to your connection wires, and then the brown goes into VCC 5 volts, the black into pin 2, digital pin 2, and then your blue into ground. So we move on to the IR sensor. It also has 3 pins: the out, the ground, and the VCC. So to connect it, just attach a jumper wire to the pins like this: out, ground, VCC, and then you connect them to your Arduino. VCC to 5 volts, ground to ground, and then your out to digital pin 2. So alright, let's start with the E18 proximity sensor. So we'll test it. Plug it into your computer. So as you can see, our serial monitor starts to show that an object is detected as I move my bottle in front of it, and then when I move my bottle out of view, no object is detected. So next we test the IR sensor, and I'll just do a brief connection. Alright, so now we test our IR sensor. So as I move my water bottle in front, you can see it says object detected. Yeah. In this comparison, we successfully evaluated the E18 proximity sensor and the IR obstacle avoidance sensor. We observed that both sensors can successfully detect objects, both provide digital output signals, both are easy to interface with the Arduino system. However, the E18 proximity sensor offers longer detection range and greater reliability, while the IR obstacle sensor offers lower cost and a more compact design. The best sensor ultimately depends on the specific requirements for your project. If you found this comparison helpful, don't forget to like, share, and subscribe. For quality electronic components, check out Up360 Circuits. Thank you for watching, and I'll see you in the next project.